Welcome back to the second part of the third paragraph. In the previous part, we looked at logical equivalences. We defined what equivalences are about, and we were looking into more possibilities, how to have some laws that we can use to prove equivalences, or a set of proven equivalences like the identity laws, the distributive associative laws, and so on. In this video, we'll be looking more into the De Morgan's laws. So we will be working with those two laws that we mentioned in the previous video. Now, when we look at associative laws and we look at multiple propositions, we can refer to the associative laws for disjunctions and conjunctions. We know that P or Q or R is equivalent with P or Q or R, whatever the order of the operation is. The same for the conjunctions. And what we can do now is we can, in fact, introduce multiple propositions. Instead of just one proposition, we can say that for the disjunctions, we can say we have P1 or P2 or Pi up to Pn. Or we can say this is the n-ary logical OR from I equal to 1 to n from Pi. And for the conjunctions, we can say that this is the n-ary logical AND for I equal to 1 to n for Pi. So basically, this is a different way to write those associative laws, to write it for disjunctions and conjunctions. And we'll be using that later in some other applications too. Now, let's have a look at the associative laws and the De Morgan laws. We can extend the De Morgan laws because we have the original law, not P and Q is equivalent with not P or not Q. And we can expand it to more propositions. So we can say not P1 and up to not Pn is equivalent with not P1 or up to not Pn. So basically we have the expansion of the De Morgan's laws in this new description. And we can also write it using the n-ary logical AND and the n-ary logical OR. So we have the not logical n-ary AND from I equal to 1 to n for Pi is equivalent to the n-ary logical OR from I equal 1 to n of not Pi. So this is a more general way to write the De Morgan's laws. And this is the first law. We can do the same for the second law. And in the second law, we had not P or Q is equivalent with not P and not Q. And we can extend it, not P1 or up to or Pn is equivalent with not P1 and not Pn. So it goes from 1 to n. And we can use the n-ary logical OR and. So not n-ary logical OR for I equal to 1 to n of Pi is equivalent with the n-ary logical AND I equal 1 to n of not Pi. So we basically have a different way, a simpler way to write the extension of the De Morgan's laws when we have more propositions. Now, the Morgan's laws tell us how to negate conjunctions and how to negate disjunctions. And what we can do, we can say that the negation of P and Q is equivalent with the disjunction of not P and not Q. So we have the negation of the conjunction of P and Q is equivalent with the disjunctions of not P and not Q. Now, this is a very good way to use these expressions, and the same we can do for the other law, the second law, the negation of the disjunction of P and Q is equivalent to the conjunction of the negations. So we can use this in some different applications, and it's very important that you understand these laws very well because they're very important in propositional logic. We'll have some example related to the De Morgan's laws. First of all, we have the expression Maria has a BMW and she has a Louis Vuitton handbag. Now let's have a look. We can say that the proposition P is Maria has a BMW, and the proposition Q is Maria has a Louis Vuitton handbag. Now, with the De Morgan laws, the first law we can say not P and Q is equivalent with not P or not Q. So when we say we have P and Q, and we can transform it in not P and Q, and we can write it as the equivalence that we have not P or not Q. And then the negation becomes Maria does not have a BMW, or she does not have a Louis Vuitton handbag. Another example, when we look at the other law of De Morgan's, we say Luc will create a new YouTube video, or Erica will create a new YouTube video. So P will be Luc will create a new YouTube video, and Q is Erica will create a new YouTube video. Using the De Morgan's law for a disjunction, we say that not the disjunction of P and Q, not P or Q, is equivalent with the conjunction of not P and not Q. So let's start from P or Q. So we take the negation, which is not P or Q, and we use the De Morgan law, which becomes not P. And not P is Luc will not create a new YouTube video, and not Q is Erica will not create a new YouTube video. Basically, we find that the negation becomes Luc will not create a new YouTube video, and Erica will not create a new YouTube video. So these are some examples that we had about the De Morgan's laws, how to use them, how we can negate a conjunction and a disjunction. And in the next session, we will look at the creation of new logical equivalences. We will define them and we will discuss them. So you're doing a great job. It's not always so easy because there is a lot of material to cover. There are a lot of new things that we are talking about. Anyway, I'm sure you're doing a good job, and I'm looking forward to seeing you in the next presentation. Thank you, and bye-bye.